First, I may introduce you to the introduction of differentiations. Differentiation is a fundamental concept in calculus that refers to the process of finding the derivative of a function. The derivative measures how a function's output value change as its input's value change. In simpler terms, it tells you the rate of change or the slope of a function at any given point. For this part, I'm going to talk about the technique of differentiations. The technique of differentiations consists 6 parts of rule, which I will explain to you the 3 part of each in the slides. So first is about constant rule. Constant rule, which the formula is d over dx is equal to 0. For the second one is power rule, which is d over dx x power of n is equal to n x power of n minus 1. For the third rule, which is sum and difference rule, sum rule is d over dx fx plus gx is equal to fx prime plus gx prime. And for the difference rule, d over dx fx minus gx is equal to fx prime minus gx prime. For this part, I will explain to you about the 3 other rules, which is the product rule, the quotient rule, and chain rule. So for the product rule, the formula is d over dx u times v is equal to u prime v plus u v prime. For the quotient rule, d over dx u over v is equal to u prime v minus u v prime over v squared. So for the chain rule, the formula is d over dx fjx is equal to f prime gx multiplied by gx prime. For this part, I'm going to talk about the problem statement that we have faced in these slides, which consists of 4 questions. For question 1, explain the meaning of differentiations and what are the technique of differentiations. For this question, I have been talk about this in the earlier part of the slides. So we are going to talk about the other questions, which will be represented by the other members.
Assalamualaikum. My name is Adam bin Sulaiman and I will answer question 2. For part A, we need to let u equal to 3x squared and then we need to differentiate u by bringing the power of x into the front, which is 2. After that, we need to minus the power of x by 1. And then the answers we will get is 6x. That will be our u prime. And then we need to do the same to the other terms, which is v equal to secant x plus 2. We need to differentiate v with respect to x by rewriting the equation back, which is secant x plus 2. We then differentiate secant into tan, and then we need to write x plus 2 back into the equation. And then finally, we need to differentiate x plus 2, which is the answer is 1. And then finally, our v prime will be secant x plus 2 tan x plus 2. To get our dy dx, we need to use the quotient formula, which is u v prime plus v u prime. We substitute our u and u prime and v and our v prime into the quotient rule. And then we need to use factorization to get secant x plus 2 times 6x plus 3x squared times x plus 2. And lastly, we simplify it further by getting the final and best form, which is 3x secant x plus 2 times 2 plus x tan x plus 2.
For part B, we use the same steps as part A in the beginning to get our u prime and v prime. And then we need to use the quotient rule by substituting our answers into the quotient rule. After that, we can separate the equation into 2 different terms. After separating them, we should replace the current terms with different terms using the trigonometric equations. And lastly, we should also factorize them to get the best possible answers.
My name is Ahmad Azri Rizak, and I'm going to answer question 3, which is involving using implicit differentiation. So without further ado, let us start. So the equation given to us is y ln 3x minus exponent power of 2x plus 1 minus tangent for y equal to 0. So for the first step that we are going to do is by differentiating all of the equation. So we can rewrite it by dy dx bracket y ln 3x minus exponent power of 2x plus 1 minus tangent for y equals to 0. By this equation, we can split them into 3 different terms, which is the first term, y ln 3x, the second term, which is exponent power of 2x plus 1, and the third term, tangent for y. So for the first term, we can rewrite it by writing d dx y ln 3x. So for this term, we can solve it by using the product rule, which is equals to uv prime plus v prime. So in this case, we are going to let y equals to u, and we are going to let ln 3x equal to v. To find uv prime and vu prime, we are going to differentiate both of those equation, which is for u prime, we differentiate y and it's going to become dy dx. And for v primes, by differentiating ln 3x, we are going to get 1 over x. So after we are done with that, we can just put in all the equation into one, which is going to be y times 1 over x plus ln 3x times dy dx. For the second term, we can rewrite it by writing d dx equals to negative exponent power of 2x plus 1. To differentiate the exponent, first we are going to rewrite what's in the brackets, which is negative exponent power of 2x plus 1. And then we are going to multiply it by the differentiation of the power, which is 2x plus 1. So by differentiating 2x plus 1, we are going to get 2. So we are going to use that 2 to multiply with negative exponent power of 2x plus 1 to get the answer negative 2e power of 2x plus 1. So lastly, for the third term, we are going to differentiate negative tangent for y. So to differentiate this term, we are going to use the chain rule, which is equal to tangent fx equal to secant square fx times f inverse x. So by applying that rule to this term, we will get negative secant square for y times d dx for y. By differentiating d dx for y, we will get negative secant square for y times 4 times dy dx. It is because when we differentiate for y, we are going to get 4, and by differentiating y, we will get dy dx. So lastly, we can combine all those three terms by rewriting y times 1 over x plus ln 3x times dy dx minus 2 exponent power of 2x plus 1 minus 4 secant square for y times dy dx equal to 0. So the next step we're going to do is we're going to separate the terms with which has dy dx to the left, and the term that doesn't have dy dx, we are going to move it to the right. So it will be ln 3x times dy dx minus 4 secant square for y times dy dx equals to 2 exponent power of 2x plus 1 minus y over x. In case you don't know when I got 1 over x, basically I multiply y times by 1 over x. So it will get y over x. So for the next step, we are going to factorize dy dx from the term, which is going to be dy dx in the bracket ln 3x minus 4 secant square for y close bracket equals to 2 exponent power of 2x plus 1 minus y over x. So lastly, we're going to make dy dx as the subject. So it is really simple. You just rewrite the 2 exponent power of 2x plus 1 minus y over x over ln 3x minus 4 secant square for y. So that's the answer for this question.
Assalamualaikum, my name is Muhammad Izzat. In this slide, we're going to discuss question 4. As you can see, I have labeled it into 4 parts. So let's start. First one, let fx equal to x power of 1 over 4 minus 2x power of negative 1 over 2. It's simple. To make it simple, and it's exchange 80.99 to become x. That's why we got x. So second one, differentiate. Become f prime x equals to 1 over 4x power of negative 3 over 4 minus negative x power of negative 3 over 2. So differentiate is very easy. You need to use power and you're going to multiply with the x. That's why we got 1 over 4x. And the power you need to minus 1. That's why we become negative 3 over 4. Same also to the next. But the final answer is going to be 1 over 4x power of negative 3 over 4 plus x power of negative 3 over 2. It becomes plus because negative move negative. Many people do these mistakes. The third one, separate it. You make sure that x we know is 80.99. XO is like the nearest point with x. That's why we take 81. And delta x, as you can see in my notes, delta x represents a small change in x. So it has one formula, which is x minus xo. And the answer is going to be negative 0.01. And the last step is use the formula. Fxo plus f prime xo multiplied with delta x. Xo we already know, which is 81. So insert inside the formula. So the answer is going to be for each going to be 25 over 9 plus 31 over 2,116 multiplied with negative 0.01. So the answer in the calculator is going to be 2.777671468. But it says correct to 3 decimal place. So it's going to be 2.778. So that's all for me. Thank you.
In conclusion, we need to master all the rules, including the product rule, the quotient rule, and chain rule, to strengthen our foundation. Next, we also need to know how to recognize the function structure, which rule that we need to apply in the function, and how to simplify using algebra or trigonometric identities. Lastly, we also need to practice problems daily to enhance our current skills.